Hello, ladies and gentlemen. It's quite an age. My name is Joshua. I'm your tutor in Eco Software Consulting, and it's my pleasure to welcome you to data description with charts. Usually, when you are doing a project, it's always very important to know how to obtain publication-ready charts, and that is what we shall be doing, particularly trying to do it with minimum codes. So we'll be dealing with the best type of packages that you will use and getting the best with minimum code. That is the ideal thing that we want to go through today. And the first thing we're going to learn is how to create a synthetic data for what we want to do. Sometimes if you rely on data from work done by some other people, you may be intruding into their privacy. So in order to avoid all these privacy use, plagiarism use, and so on, sometimes it is the best thing is for you to create a synthetic data, either to test theories or to learn how to work with some out packages and so on and so forth. And that is the line that we are going to follow today. So the starting point is creating a synthetic cross-section data. We will produce it for output, label, capital, material, age, sex, and size. Picture in your mind that we are trying to look at performance of a manufacturing firms. So we are interested in the output. Let's say the output is sales, then labor, capital, labor in terms of number of employee, capital in terms of the book value of building and machinery, material in terms of the cost of intermediate inputs, age, let's say age is the age of the manager, sex of the manager, then the size of the firm. To create the synthetic data, the easiest way is to use Cebu package. So library, Cebu. Don't forget, if you don't have the package, you have to install it. But to install, just click on Tools, then you see Install Packages, then follow the instruction. Let's set the seed, set.seed. To be able to reproduce what we are trying to do. Let's say we want to deal with 40 respondents. So we say RESP equals to 40. So let's call the data we want to generate data, let's say data 21 equals Cebu. Our ID equals 1 to RESP, that is to 40, that is respondent 1, 2, 3, up to 40. Then our output, as let's say round R norm RESP for the number of respondents. Let's use the mean of 20,000. Then we need the standard deviation. Let's say the standard deviation is 6,000. Label rand. Oh no, let us, since it's number of employees, you can't have that in terms of percentage or thereabout. So let us maintain it as integer. So we have as dot integer. Then R norm. So we have RESP, is the number of respondents. So let's say the minimum equals to 4. Oh, we use run if you want to use run if you want to use minimum and maximum. The maximum, because we are talking of number of employees here, the maximum, let's say the maximum number of employees is 10. Material equals rand R norm RESP mean. Let us for material, let's use let the mean be 7,000 and the standard deviation 1,000. Then we have capital. So capital equals rand R norm RESP. Then let the mean, let's use the mean of 12,500. The standard deviation of 500. Age, rand R norm RESP. Let the mean age be 45 and the standard deviation, let's say it's 14. Then sex. Let us not forget sex is a qualitative variable. So sample. We have two attributes, male, then female. Then RESP, number of respondents, replace equals to true. Then we have the probability now, PROB, probability, let's see, let the probability of male be 0.6, which means that of female will be 0.4. Yeah. Then we have size. Size also is a qualitative variable. So we have sample C. Let's say we have small, medium, and large scale firms. Large scale firms. Then we have RESP, replace is equal to true. So then the probability. So probability. So let's say the probability of small is 0.7, 0.7. Let's say medium is 0.3 and large is 0.1. So let's shift this here. So this is how to create the synthetic. So let's run from line 8 to the end here to line 18. Run. Yeah, beautiful. So let's check the first 6 observations. So we have edge, data 21. So this is the data we want to use. We can see the ID, the output, the label, the material, capital, age, sex, and size. Take note, we use round in order to round all the figures to whole number. If you want to maintain certain number of decimals, before the last bracket, you will just say comma, then you put the number. If you put 2, it's going to be 2 decimal places, 1 decimal place, and so on and so forth. So, but I want everything to be in whole number. That is why I've not included the digits. Okay. So now we have generated the data that we need. So let us begin to describe the frequencies of our variables, particularly the qualitative variables now. The first one we want to do is to learn the use of Pareto chart. Pareto chart. So we have plotting Pareto charts. Pareto chart is a bar graph. That is the first thing. And it's going to arrange the frequencies, okay, which arranges the frequencies in descending order of importance. In descending order, let me use that shorthand, order of importance. So let's try and use it for size, for instance. So if you want to learn how to use Pareto chart, the starting point is to create the data set, but you need QCC package to do that. QCC package. So QCC package. Let's generate the frequency. Let's say size underscore freq. Let's, to save time, underscore f equals table the name of our data set, we call it data21. So if you click on dollar, that is $sign, it's going to give you the list of all the variables. And the variable of interest now will be size. So let's run this. So you may want to look at the frequency, size underscore f. So run it. So this is showing you that we have 25 small scale firms, 9 medium scale firms, and 6 large scale firms in the 40 firms that were interviewed. Okay, that we generated actually. So let us plot it. To plot it, you need Pareto.charts size underscore f. So let me move this here so that you can see clearly what we are trying to do. So run this. Yeah, so you can see that small scale has the largest number of frequency. They are more in number compared to medium and large. And the percentage, cumulative percentages are actually calculated. So I think it's better. Let's look at what we can do to improve the charts. Usually, I don't want the title to appear here. So I want to remove it. So if you want to remove it, you say main equals, main is the title. So since I've not written anything within the quotes, it's going to remove it. So run. You know it's no longer there. Another thing, I may not be comfortable with this color. adventure, I want to use another color sharper than this. So just say col equals col is for color. Let's see it dot colors. Then you will have to use the length size underscore f. Yeah. So if you have done this, let me move this so that we can see clearly what we're trying to do on the graph. So let's run this and see. Yeah. You may still want to explore another opportunity, maybe if you want to use rainbow color. If you want to use rainbow color, you just change this to rainbow. Just click rainbow here, then run. Yeah, I think I prefer rainbow. It's sharper and clearer than the other pictures. So it's your choice actually. So, but that is a simple way to plot Pareto charts. So another way to plot frequency charts, particularly when you are dealing with single variable, is the use of pie chart. Pie chart. So we move to pie charts. Pie chart. For pie chart, if you are dealing with just a single variable situation, you can just use the very fast way, tastypie. Use tastypie package. So again, we have to generate the data. So let's say data for pie charts. So let's use size. So let's call it size underscore pi equals data dot frame. Then you have table, just like before, table, but we want it to appear in data frame. That is why we put data frame there. Table, then again we have the name of our variable is, the name of our data set is data21. Data21 $. So in this case, we are dealing with size. Okay. All right. So let's run this. Oh, beautiful. So now to plot, you need I hope did we run this tastypie? And let me do it again. Okay. So we have pie bake, just like as if you are baking, something. Anyway, before pie bake, check what size pie. You can see that it's made up of just two variables. You have the var1, then freq. So which arrange the frequency of your size. 6925, that is ascending order. So let's try to plot it. So we have pi underscore bake. So now we have size underscore pi, that is what we are going to use now, comma. Then templates, there are so many templates. So templates, you can start with basic template, that is basic one, comma. Then if you want to include a percentage, say PERC equals to true. As simple as that. I want to see the plot very well. Run. Yeah, you can now see. So this is showing off that for small scale firms, 63%, then medium, 22%, and large scale just 15%. You see, you can play around with so many templates. For you to understand the number of templates that you have, or study any package, what you need to do is just go to the package itself. We are dealing with tastypie, so just look for tastypie, tastypie, tastypie. Okay, this is it. Just double click on it. Then you see all the documentation. So go through the documentation, and for instance, now if you want to learn how to use PyBake, just double click on PyBake. So, and if you will see examples, you will see the usage and so on and so forth. So if you want to look at the list of various templates you can use, you say type file underscore template underscore list going to give us. Okay, even let's try that here. We have file underscore templates underscore list. So then run it. So you can see, so you can play around with as many as possible. Now I'll be playing around with the basic. For instance, I can change this basic to basic 3. If I have it as basic 3, for instance, and run it, it's going to give me another color. So it's your choice. And if I want to turn it to donuts, let's have donuts. Look at the spelling of donuts, because it's D-O-N-U-T here, so that you don't miss it. 3. So you can pick anyone. So most of them is just changing the color, you can see. So it all depends on you. So this is a very straightforward way of plotting pie charts, particularly when you are dealing with single variable. But sometimes you may want to use donuts to consider two different categorical variables. In our situation, we have sex and size. Let us see how to go about it. It's very, very informative, actually. And I would even like to recommend that you keep using the next one we want to use. And it's very simple with minimum code, then you get a very fine results. So we have plotting donuts with two variables. Now you can actually plot, you can change it. The beauty of this is that you will see as we proceed. You can change the donuts to pie chart. So simple, very, very simple. So we need library tidyverse. Then we need another package, webr. So let's load those packages. Okay. So in this case, we have to generate the data set. So let's call it pi underscore. No, we are dealing with do not. So let's say not underscore data equals. So here is data 21. Percent greater percent, that is a pipe operator, which means then that is you have this data 21, what do you want to do with it? So in this case, we say group by. I want us to use the group by in, you can see a lot of group by here, but the group by I want us to use is the one in ggplots, and it's not coming out. So when you are using a package and the code you want to use is not coming out because you have similar code in several packages that you have uploaded or that you are using. A way out is you just type that ggplyr, for instance. Then you have these two dots. You do anything like this, it's going to give you list of all the functions. Then you will look for the function that you need. So you can see this is the group by that I needed. So I'm 100% sure now this is group by from ggplyr. That is how to do it. So group by, I have two variables. I have sex, then I have size. Those are the two qualitative variables that I have. Then I have percent, greater percent. Then we need summarize. So I want to create a column named n, that is the number of, the frequency count. You can call it count frequency, but I just call it n. This is the number of observation. So equals to n. That n into brackets in front is showing you that I want it to give me the number of observation. So run it. So you can see that I said as group output by sex. So, and you can overwrite using the group agreement, whichever. So now let's check how it looks like. So not data, run it. So you can now see clearly. Now you have sex, size, and the number of observations. You have female large, female medium, female small, male large, and so on. That's how the data has been generated. So we want to now plot the do nots. So the function is pi do nots. You can see it's in webr package, pi do nots. So you see data equals not underscore data, comma, then AES. So you have sex. Then you have size. Just check the labels on the sex, size, and n size. Then you have count equals to n. That is all. So let's plot this and check the results. Yeah, you can see clearly. So you can see this is when you have sex here. Then you have male and female. So this is when you have 62% male, 38% female. But coming to the male section, it's showing you that 68% of the male have small scale firm owners. Then 16% operating medium scale firms, while 16% of them had large scale firms. You can see. So you can see, if you look at the percentages of the small, medium, large for each category, you should add up. It will give you 100. But if you want the addition to be exactly 62%, this is what we have to do. So let's copy this to save time. So copy, paste it there. So then you will have to include customer, say ratio by group. So say ratio by group equals to force F. No, that should be capital F. So run this. Yeah, you can now see clearly that if you look at this 42.5, 10.0, and 10.0. So if you add it, you get this 62%. Likewise, this, if you add this, you get your 38%. Yeah. All right. So it depends on you. Then, like I said, you can turn it to, if you want to turn it to pie charts, it's very, very simple to do. To turn it to pie charts, what I will do, instead of ratio by group here, you can still include it if you want. I'll just say explode. Explode equals to 0. If I say explode equals to 0, then it's going to give me R0, not explode. R0. Sometimes that's why sometimes you have to read some of these things or go back to where you have the code. Yeah, exactly. So this has converted this to pie chart. If I want to return it to donuts, just increase the size of your R0. So let's say this 0.6. So yeah, simple as ABC. So you can shrink the size, you can expand the size, and so on and so forth. So this is how to turn your donuts to pie chart. Yeah. So let's try and again, as we have R0, R0 is dealing with this inside, but if you want to deal with this outside this box, then that will be R1. So I can say R1, I can expand it, R1 equals to, let's say, 0.6, for instance. It's going to expand it. No, oh, sorry, we didn't put comma here. So, wrong. Yeah, beautiful. You can say that, hey, that's too big. So let's reduce it to something like 0.3. Yeah. So it all depends on what you are trying to achieve. Yeah. I want to stick to the suggestion from the package. Let's try it for just for single variable. The advantage of this one, the number of code is very minimal. Then by the time we use when we use tastypie, we have the percentages, then we have the legend outside. But in this case, you can actually have both the label and the percentages inside the chart. So let's try to do that here for single variable. So let's say we have for single variable. So for single variable, again, don't forget, we just have to generate the data. So let's call it S data equals, so that is data 21% greater percent. So again, in this case, we have group by. Okay, since we have too many group by, so ggpubr. So come here and group by. Now in this case, we are grouping by just one variable. So let us use size alone. So and you have percent greater percent. Then you have summarize, just like we have the other time. Summarize n equals n. So you run this. So you may want to check your S data, for instance. So run it. So you can see that here we just have just a single variable, like the case of, like the one we use for tastypie. So, and to plot it, just the same. We have pi donuts. So our data now equals S underscore data AES, and you have, in this case, we are dealing with size. Then our count equals to n. Yeah. So let's draw this. Good. So if I want to turn it to pie charts, I will just say RO, and see it's very simple, equals to 0. No, very minimum number of codes, just like 2 or 3 lines. Okay. He's complaining about my RO. Oh, sorry. I know I got it wrong. I did not close my AES. Sorry, it should be here. So RO equals to 0. Run. They are beautiful. So it's very, very clear and straightforward to do. So, and if you want to take your graph to or chart to Excel, just click on export there. You can save as image, you can save as bitmap, you can save as PDF, or you can copy to clipboard. Just say copy plot, then you take this to Microsoft Word. Straightforward to do. Yeah. So, and that takes us to the next type of plots for describing our data. That is box plots, box plots, box plots, and Violin plots. Violin plots. Yeah, let's see. Let's wait for just single variable, one var situation. Okay, so in this case, you need, because we are dealing with publication ready charts, yeah. So you need this ggpubr, that is publication ready, as well as ggplot2, which is the most popular package for plotting charts in R. Okay, so let us not forget the use of Boxplot is to graphically show the median, the first quartile, the third quartile, then the error bar, then the outliers. These are the main functions of Boxplot actually. So let's call the Boxplot BXP equals ggboxplots. You define your data, that's data 21, comma. You define your x-axis. So let's say our x-axis is size. So we want different box plot for different categories, comma. Then our y, which is the continuous variable in this situation. So let's do it for each. Okay. So let's say let's plot this and you will see the need for various correction we want to be making. So run. So BXP, run it. Yeah, you can see that the result actually came out, but the box is empty. So you can read it anyway because the middle line is the median. So, which means the median scale firms has the largest median, and the lowest is with the landscape frames. So now, and in terms of variance, you have more variance in landscape among landscape frames compared to the other ones. All right. So let us make few adjustments. We can say fill equals, so you can actually use one color of your choice. So let's pick a color. Let's pick color red. So run it and obtain your BXP now. Yeah, you can now see that it has shown us the color that we defined, which is color red. Yeah, let's try to do the same thing for Violin plots. Let's call our Violin plot VP. So VP equals ggviolin, ggviolin. We have data 21, comma, let's our x equals, let's our x be size, our x is size, our y equals to age. Okay, let us add a choice, the mean standard deviation, mean underscore SD. So you can, let's run it and type, that's V, we call it VP, so run it. So you can see, then again, maybe if you want to fill it with another color, for instance, let's pick another color. Let's say fill equals to blue. It works fine. Okay, we didn't put comma here, sorry. Yeah. Okay, it doesn't work with the fill. Yeah, you may want to actually go to help in order to see how some of those things work. So you can go back to the package, for instance. We have, go to ggpubr, ggpubr. Okay, so double click. Yeah, I'm interested in G now, that is ggviolin. So this is Violin plots. So you can look at various options. Yeah, so there are quite a lot of options. So you can try and play around with as many as possible. Okay. All right. So you can play around with it. But that is how to quickly go through and learn the usage of the function. ggpubr has one advantage which I want you to explore. It can help you to arrange your charts into a table. Call it panel. You can get panel of your charts. So if you want to do that, very, very simple. The function is ggarrange. Ggarrange. So ggarrange, we've add 2 here. We have bxp, comma, we have vp, comma. Then you can decide the number of column. In this case, definitely it's going to be 2 column. 2. So you have this is going to place here. You can see very clearly. Yeah. Okay. Yeah. This the one when I added the blue. All right. So this is how to arrange it. And let's say you have about 4 or 5 or 6, depending on, then you can have number of rows also covered. And that takes us to the next thing we want to quickly learn, and that is plotting box plot with multiple panel. So we have box plots with multiple panel. So let us have our BXP. Let's call it BXP2. BXP2 equals ggboxplots. Our data, that's data 21, that's what we're using, comma. Define your x. Let's say our x is size. Then we talk of multiple panel when you have more than one y. That is, you have more than one continuous variable. So in our situation, for instance, let us say we want the plot of labor, the plot of labor, the plot of capital, the plot of material, the plot of output. Okay. So, comma. So now, because I'm dealing with multiple y, so there is a function combine. So combine equals to, I may combine and I may not combine. So, and let's get field. Let's get a color. I think I'm in love with a red color. So, so let's run it and see. Then here you have BXP2, BXP2. Then run it. You can now see, now you have the different plots. You have the plot of labor, the plot of capital, the outputs. If you just go back, this is material, this is capital, this is labor. So the plot of various variables, they are plotted differently. So, and this is where degree um, the ggrange is very, very useful here. So let's say I want to create just a panel of all the plots. It's very straightforward. So just say ggrange. So ggrange, we have bxp dollar, sorry, bxp2 dollar. The first one is labor, comma, bxp2 dollar capital, bxp2 dollar material, bxp2 dollar output. So that is how to obtain. Then you have to define the number of end call. But this is a 2 by 2 stuff. So it's equal to 2, comma, then end row equals to 2. So if you have it this way, let's run it and see how the output look like. Oh, sorry, saying I have equals, should be equal to. So run. Yeah, so you can see clearly now, this is, you now have panel of plots for labor, capital, material, and output. I can export it to your Microsoft Word or wherever you want it, either as PDF or as image. Another thing I want us to quickly learn is you can have different color for different categories of size. You know, you have small, large and medium. Yeah, if you want to do that, then just follow what I'm trying to do. So to save time, let us copy our BX2, copy BX2 up to fill. So copy. So let's come here. So what we want to learn now is different color for different size, categories of size, so different color for different size categories. All right. So we have different color for different size categories. So paste. So what we just need to change is fill. So instead of red there, just put size. Then we will now define the palettes. So we have palettes. There are quite a lot of them, but the one that I love most is GCO. JCO. Yeah, you can share the documentation. There are quite a lot of them there. So let's run this. Run. Then you will have your BXP2. You can now see clearly using different color for, and can have the legend up there. So, yeah, you can now use ggrange in order to have them together as one chart. Um, let's try to do that. Ggrange. Yeah. So for ggrange, so that's ggrange. So for ggrange, we have bxp2 dollar label, comma, bxp2 dollar capital, comma, bxp2 dollar material, comma, bxp2 dollar outputs. Then you define your number of rows, n rows is equal to 2, n call equals to 2. Then there is something I want you to add. Common legend. Because if you don't put common legend, it's going to add legends to each of them. So, or if you just want one legend, because it's the same color for small, same color for large, same color for medium, whether you are dealing with labor, capital, material, output. So you say common.legend is equal to true. So if you have done this, run it. Fantastic graph, you can see. Very clean, very clear. So you can export it. You can see this is publication ready, presentation ready too. So because there is nowhere you present this kind of objects, and they will know you have done your homework very well. So another way to look at or to describe our data is the use of histogram. 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 And the function is gg histogram. So let's say gg histogram data 21, comma. Again, you define your x. Let's say my x is age. And let's say I want to get a field. I use sex for that, so that I distinguish my histogram by sex. Sorry, comma and this full stop. Then let me add the mean, that is the mean of age. Yeah. Then another thing you may want to do, you can say facet dot by equals to that particular variable, which is sex, that is the disaggregating variable. Let's run this, then we may be adding one or two things. Yeah, if you look at this graph, you can see it's showing us the graph of female and male separately. That's because we add facet dot by equal to sex. If you don't add it, it's going to plot male or female. So yeah, you will have the two together in just one plot. And that could be messy. So I think it's better this way. But if you look at this graph, yeah, there is a warning message that you may want to use to your own advantage. Say using bins equals to 30 by default. Pick better value with the argument bins. So I may want to say bins. So pick it here, bins equal to, let's use 15. We see the changes so that you have something bigger. Yeah, you may have it as 10. I think 10 would be clearer for this kind of histogram. Yeah, beautiful. So, and for you to quickly see the types of distribution, if it's normally distributed or not, you can impose the density function. So if you want to impose the density functions, just say add underscore density equal to true. Then run it. Yeah, you can see it clearly there. Yeah, so that is how to plot histogram. Very, very clear. If you don't want to disaggregate by anything, just remove the whole of sets, then go ahead. It's going to show you the histogram for that particular data set. So another way to depict your data set is the use of bar charts. Bar charts. So plotting bar charts. For bar charts, you must, just like we did in the case of pie charts and donut charts, you must first define the data set. You must first obtain the data set. So let's start with bar chart for single variable. That is, we just want to describe the frequency of just a variable. So let's generate the data. Let's call it bar underscore data equals data 21% greater percent group by. So let's use size. Then percent greater percent. Then summarize. N equals to N. So run it. And let's look at our data set. Bar data. Run. So we have our 6925. All right. So the function for bar chart is ggplots. So we have ggplots. So our data set now will be bar data, comma. So we have x, our x equals to size. That is its size. Then our y, that is the n, the number of observations, as the frequency. N. So we want it to put the label, so that's label equals to true. Where do you want the label to be? Label does POS, that is label position. I want it to be outside. put it inside to change. We'll change it after plotting. My while I want my y-axis to be labeled as frequency, because actually frequency counts. Okay, frequency. Let's start as capital. So run this. So you can see beautiful. Okay, the only problem is that we do not add the field, so it's empty. So let us put the field. So let's come here, field equals, you can use a color, desire one color. Let me use red. So run. Yeah, you have seen it now. Beautiful. But if I need different colors for different charts, I will just put size here. So run. Beautiful. If I want the labels to be inside, I will put in here instead of out. Run. Beautiful. So very, very straightforward to plot. Very simple. So, and that takes us to multiple bar charts. So this is a situation whereby we are dealing with more than one variable. So multiple bar charts. Yeah, sometimes if you have been working for quite a while, at times you need to remind yourself the column names so that, well, you are not making typing errors. So names, data 21. So just to remind ourselves the column names. So, but don't forget, we just have two categorical variables, sex and size. And that is what we're using to, that's the frequency distribution we're trying to plot. So we need to obtain the data. Let's call the data m bar, and that's called data. So equals data 21% greater percent group by sorry, the group by for GPLY is not coming out, GPLYR. So I need to be sure I'm working with, that is group by, come out now, group by. Now we are grouping by sex and size. So we have percent greater percent, age greater percent. So you have summarize n equals to n, run. So try to look at m bar data. So beautiful. We have generated the frequency table to plot, to have our multiple panel plots. So here we have ggplots. Our data set is m bar data, comma. Our x is equal to size. our y is equal to the frequency, which is n. Then our field, we want the result to be by sex. If you like, you can change your x and field. Your x can be sex and your field can be size. It depends on your feeling. Then label equals to true. Want the label to be included. Label lab dot position is equal to let's put it inside then palette. So palette, I prefer GCO. So let's plot this out before we continue to make. Yeah, you can see super clear, beautiful plots. So, and don't forget this is stack. This is in stack form. So, and if I were you, I would make a few changes here. I will change the label for my y-axis. So that's y-lab. My y-lab equals frequencies or frequency. Oh, sorry. That frequency should be in quotes. So frequency. Yeah. Beautiful. Yeah, beautiful plots. So this is how to do it. Another thing you can do is that you can actually, instead of having stack, you can have what is called sidebar chart. That is, instead of distinguishing maybe the category by different colors along the stack bar charts, you can have them side by side. So if that is what you want to do, the only thing you need to add is the position. So I have position equals, let me say position dot simple. Don't forget, this is not the last aspect. You have to put comma there. So let's run this. Yeah, beautiful. And if you want the label to be outside, just come here and change this to out. Run. Good. So no, very, very simple, straightforward, simple code, simple to understand, simple to plot, simple to explain. That is describing your data using bar plots. Let's move quickly to what is called scatter plots. Scatter plots. Scatter plots. Scatter plot is the easiest way to explain relationship. That's the starting point of explaining relationship. Take, for instance, I may want to look at the relationship between labor and output, and I may want to look at it by gender or by size. These are the things we want to quickly look at. And very simple to do. The function is ggscatter. So GG scatter. Your data is data 21, comma. Then you define your x-axis. Our x and y in this case must be defined. So let's say our x is labor. Then our y is sales. So we want to look at correlation between sales and labor. Before anything else, plot it and we see the way it is before we begin to make unnecessary adjustments. There is complaining of error here. Oh, sorry, it's not sales, it's output. It's output. It's output. Output, not sales. So it's so let me run it. Yeah, beautiful. So you can see the different points of labor and output relationship. But you see, the points have the same color. This is a black color. So I don't know which one is male or female, so on and so forth. So let's make small. You can say label equals to sex. That would be in quotes. Sex. Run it and you will see the changes that will have taken place. Yeah, you can now see that you have the male and female. You can now see which point belongs to male, which point belongs to female. Yeah. But it's still the same color. So I may change the color, for instance. So come here, say color. So color equals, since I want different colors, I will say sex. So it's going to give me different colors. Now, yeah, you can now see that you have different color for male and another color for female. Yeah, but for publication, I may want to use the palette, and my favorite is JCO. So run it. Yeah, no, it's getting better. Yeah, I may want to remove overplotting. If I want to remove overplotting, I will say repel. REP, yeah, repel equals true. So run. Yeah, it's clearer. Yeah, I may want to identify outliers by using star plot. It's going to, so I just say star dot plot equals to true. So run. Yeah, you can now see different lines pointing to various outliers within the plots. So you can see this is a very neat, fantastic way of producing what I normally call elegant bar plots. Simple, easy to explain, easy to follow. Yeah. So the last set of plots we want to consider is line plots. Line plots. line plots. And in dealing with line plots, um, since the synthetic data we've been using is cross-section, we need to generate another synthetic data, which is time series this time around. So let's try to do that very quickly. So let's generate synthetic daily time series. Time series data. Okay, synthetic daily time series data. Let's say for prices, prices in 4 locations. Okay, all right. So you need this package tcb. That is the easiest way to do it. Like I told you, here we are trying to get the easiest way to come out with publication ready plots. So again, you have you set your seed, set dot seed 1 2 3. Yeah. So we need price. Let's call it price D. Let's have our price data equals is table. So let's define our time. Let's say time t equals sequence. Okay, before then, I think it would be better for us to define the starting dates. So let's say our start equals as dot date. So as dot date, let's start, let's say 2020. It should be in quotes, 2020 01 01. Then we have to define the end date. So let's have our end equals as dot date. As dot date, let's say it's 2024. It should be in quotes also. That's 2024 12 31. The beauty of using the Cebu package is to take care of leap years. That's why it is better than using just TS, the time series function. If you try to use the time series function, you will have quite a lot of adjustments to make in order to take care of leap years. For instance, between 2020 and 2024, we have 2 leap years there. So, and if you just say, you define it as maybe 365, it will not work. If you say 365.25, we have to make adjustment here, unless you want to be defining year by year. So this is why it's important that you use this Cebu package. That is the bottom line. You can actually use the time series function, because I'm saying this because several people have come up with that question. and to justify the reason why I'm directing you to this Cebu package. Okay, so we have defined the starting point, the end point. So let us now define our data. So let's call our data price, uh, price that. Let's call it price that equals now Cebu. So the starting point is our time. So let's say time t, for instance. Time t equals sequence. So the sequence we need, we have start. We have defined our start. That's the essence of defining the start. Then you have end. You have defined your end. Then you say by equals to day. That is, we are dealing with something on day-to-day basis. So day, simple as ABC. So let's have it this way. So we have percent, greater percent. Yeah, so we now generate the variables of interest. So let's say mutate. Mutate is the word for generating variable, tidyverse. So let's say we have price for the first location as P1 equals, we're already familiar with this, rand R norm. Let's say the mean equals to, let's say it is 102 naira. Let's say it's just the price of roadside maize. So that's an example. Let's say the mean is 102, comma. Then the standard deviation. Let's say the standard deviation sorry. Let's say the standard deviation is 4. Okay. Comma. Then you have to define the length. No, in this case, the length must coincide with the time frame that we have defined. So it's going to be length So it's going to be length time t. Yeah, length time t, that should be. So let me, so percent greater percent. So it's just a matter of copying this to save time. Because what we'll just be changing now is copy. I don't need this. So what we need now is paste. So we change this to P2. We have another main, let's say this is 112, and let's say the standard deviation is still the same. paste. So let's say we have P3 and let's say this is 107. What are we trying to do? Let's say this is 107 and the standard deviation is 6. And paste. So let's say the last one is 115. And say the standard deviation is 2. Yeah, good. And let us add a rule of 6 so that we can maybe plot our graph by 6. So that one, in this case, will be mutate 6 equals sample, done it before, sample, we have C. To save time, let's see our male is M and our female is F. Then we have length time T. Then you have replace is equal to true. Then you have the probability, prob equals C. So now let's say we are dealing with 0.2 for male and 0.8 for female. So if we have done this, so the last thing will not be percent, greater percent, so that we have our as as.tcble to define our index. So our index is equal to time t. So that's what we have defined. Time t. Yeah. All right. So let's try and run it from price that here. Okay, let's pick it from, so that it's going to identify this, that, whatever. So from set seed to the end. Okay, so run. Oh, think we have error in the argument 6. So it's saying incorrect number of probabilities. So I'm thinking of where the probability is wrong, some sort of. So we have sample C, define our male and female, length, replace is equal to true, then probability. I'm still looking for where we got it. where it might have gone wrong. So let's, oh yeah, this is point, not, yeah, sometimes, yeah, 0.8, not 0.8. Yeah. So it's identifying it as three numbers instead of just two. So let's run it now. So beautiful. So now you may quickly look at the data set. So let's say add price that. So let me move this to a little bit so that we can see clearly the data set. Yeah, so here we are. So you can now see you have P1, P2, P3. Oh, we didn't generate P4. Seriously. Whoosh! Sorry, we're supposed to change this to P4. You can see sometimes when you are working, always make sure that you check what you are doing. Now, this could be the problem of copy and paste action. So let's run it again. So I run it from set C there. Yeah, everything's supposed to run very smoothly and well now. Yeah, beautiful. So I now have my data P1, P2, P3, P4, and sets. So if you want to look at the last 6 observation, that would be tail, price, that, so run. Yeah, good. All right, so now let's quickly plot our graph since we now have an up-to-date data set that we're using. Yeah, so now we have line plots, line plots. So you have library. No, we already have ggplots, ggpubr. So you have ggline, that is the function, ggline. Then your data is price that, comma. Then you define your x. Our x is time t, comma. Let's start our y equals to, let's start with P1, P1. Yeah, we may want to distinguish, that's why we added, say, color. Color equals to sex. We want different colors for different categories of sex. Then we have the palettes. Palettes. My favorite is JCO. JCO. Good. So with this, let's see how the plot will look like. Said object time t not found. So time t. So let me check and run it again. Object time t not found. Objects. So this where we have time t. Let me run it and see. Okay. I just need to check what the name is in maybe let's say names price that. That's there, time T. So why is it giving me error? It's there. So let's try it again. Still complaining about this time T. Oh, sorry, it's because it's not in quotes. Sorry about that. It's a character. So time T. So wrong. Yeah, beautiful. So you can now see different color for. You can see the yellow is for male and the blue is for female. So that is it. So again, we may need to make some small changes here. If you look at the date, or the date is not showing us the month, it's not showing us the date. So you may need to make some adjustment here. And it's very simple to do. So just say plus. So you just change the scale underscore x underscore date. So, and there are two things that are always important. We have the date break, date underscore breaks. So for date underscore break, let's put months. Then we have the label, date underscore labels. So the labels, if I want just month and year, that will be percent B, then percent Y. Y is year, B is month. So if I have it this way, let's run it and see how this look like. Yeah, you can see because we have many months. That is why you can see it's very clumsy. So let's change this. Let's say we have 6 months, put 6 there. It's going to give us something better. Yeah, it's clear. We are April 20 to October 20, April 21, and so on. And if I were you, I can actually make it 12 months. So run. Can I say that it's better? Yeah, I may want to, if I want the whole of year to be written, I will just say, I will change this to capital. Run. Yeah, beautiful. And if you want the whole of um, month to be written, change this to capital B. Yeah, so it all depends on you. And if you want it to be in actual dates, I think that should be capital F. Okay, what have I done? I hope I have not deleted what needed to be deleted. So you can undo so that undo, you just click on the date, undo, all right. So this is capital F. Yeah, wrong. No, it's not capital F. It should be percent F. Yeah, wrong. Yeah, you can see that and the dates are there. So it all depends on you, whichever one you desire to use, and so on. So, but those are the various ways to manipulate the dates. Yeah, I think the last thing we want to, you can see that it's not easy to understand the seasonal variation here. So sometimes you may want to convert this data to monthly or to quarterly or to yearly so that you can see the plots in a clearer form. So let's say I want to convert to monthly. So let's say let's convert price that to monthly. Yeah, you need tidy quants. There is one thing you need to learn. In manipulating cross-section and panel data, you need tidyverse. But when you want to manipulate time series data, you need tidy quant. So that you will not be studying them one by one. In tidy quant, you have so many packages, all these lubricate, zoo, so many of them are just there. Just like tidy, um, in tidyverse, you have a lot. You have your ggplots, you have your dply, you have your tidyard, you have so many things. It's the same. So when you are dealing with time series, you just need one package that combines a lot of them. That is tidy quant. So don't forget what I've said. For cross-section, panel, tidyverse, time series, tidy quant. I think it's very simple. So run it. So now price time series. I need to generate my TS equals to, you use zoo. So we have price that dollar is going to give us the list. So let's say we want that of P1, for instance. Then you define the sequence. You have already defined the stats. So we have stats, comma, end, comma, then day. But that's your day should be in quotes. So day. So yeah, I think that is just what you need to do. So now you have your price TS. Yeah, beautiful. So now to convert to monthly. So it's very simple. So let me see M price, I call it M price, monthly price, is equal to 2.monthly. So it's very simple. 2.monthly price TS. That's how to do the conversion. So no, you have to add the form, that is the function form. Sorry, I think no, I think so. 2.monthly. So run it and let's see. Okay, yeah, I don't need form. So I've converted this to monthly data. So I can auto plot. Let's see auto plot price. So run it. Here you can see. And if you like, you can pick the first one. If I want to pick the first one, which is the open, so you have the open, you have the high, you have the low, then you have the close. So that is the opening price, the closing price, the maximum price, and the minimum price. You can now see this becoming clearer. You can now see the monthly, in terms of the seasonal variation. Um, if you want to convert to yearly, you have, let's call that no, that's Y price. Y price. So let's say Y price equals, so Y price equals 2 dot yearly, straightforward. So you have price underscore TS. So run. Beautiful. So if you want to plot that, you will see it's going to show you the monthly or the yearly that's Y price. The plot of the prices across the years. So you can now see this is clearer. Yeah. And you can do that for weekly if you want. Yeah, other thing, let's say that just my interest is to obtain the average, just the average. I just need the average price. If average is what you want, let's say AV price equals, that's for P1. Let's put P1 there because you have to do that for other ones if you want. And that will give us apply dot, if it's monthly, you see apply dot monthly. This is average monthly price. So you will say price underscore TS, then you will say form, that is the function. It's equal to mean. Yeah, simple. So run this. So you may auto plot to see how it looks like. Auto plot AV price P1. Come here. Run. Yeah, you can see it's now becoming clearer and clearer. Yeah, you can make adjustments to your date if you so wish, but this is yearly or this is monthly, so you can still adjust to reflect that it is monthly data. And finally, if it's yearly, let's see, AV price P1 Y to show that it's yearly equals to apply dot yearly. So you can, this so simple to do the conversion. So you have price TS, comma. So you have the form equals the mean. So let's run it. So let us auto plot AV price P1Y. So run. You can see. So you can now see how we moved from daily data to monthly data to yearly data. If you desire, you can move to weekly data. You can do a lot of things. It's the same function, to weekly, and so on and so forth. They are all in HTS package, and the HTS package is part of um, the packages in tidyquant. So we have tried to explore various ways to describe your data sets. And one thing about R is that if you abandon it, you don't practice it, you can master it. So the better for you to just try, generate your own synthetic data, for instance, then try to um, go along. Maybe the starting point will be to start with what we have here, go through it, then stage by stage like that. Or if you have your data, because the reason why I've not used real life data is because of privacy issues, so that you don't end up in court because of all these things. So, but the one you have generated, you are free to use any day, anytime. So thank you. Till we meet in the next class. I remain yours, Joshua.